We'll wait for some time, right?
Yes, sir, but we can start, sir. Actually, the session was ended quite time ago.
Mhm.
10 minutes has gone.
So,
So can start
uh,
if you are okay with it.
yeah, I thought that it is to be started at 6:20. So otherwise I would have joined early also, no
Yeah,
problem.
sir.
Okay. Okay.
So,
So let me just open my slides. Give me 2-3 minutes and then we'll
yeah,
start.
yeah, sir, sure.
Okay.
Sir, just a small request, sir. I want to introduce you in front of all the participants.
Yes.
So,
I'm
small request, sir, just give me this opportunity to introduce you in front of all the participants.
Yes, please. Please.
Thank you, sir. So we are very fortunate that today we have Professor Jagdish Chand Bansal sir with us. He is an associate professor at Southern Asian University, New Delhi, and a visiting professor at Maths and Computer Science, Liverpool Hope University, UK. And before than that, he was also a visiting professor in NIT Goa and in also done his PhD in mathematics from IIT Roorkee, and before then this Liverpool Hope University and the Southern Asian University, he was also in ABB IIIT DM Management Gwalior and the BITS Pilani. His primary area of interest are swarm intelligence and the nature-inspired optimization technique, and recently he has proposed a very unique vision fusion social structural based optimization algorithm and the very famous spider monkey optimization, and which is being applied to various problems in the engineering domain. Means if you talk about the citation, if about talk about this application of this optimization algorithm in different engineering thing, so it is numerous. And he has also published over 70 research papers and in various international journals and conferences. He is the section editor or editor-in-chief of the journal Methodox, published by elsewhere. He has a series of editor of 4 Springer book series, that is AIS, SADIS, ISTC and SST by the Springer, and he is also the associate editor of engineering application of artificial intelligence, that is EAAI, and array published by elsewhere. He is the General Secretary, GenSec of the Soft Computing Research Society, that is SCRS, and that is being publishing and supporting or sponsoring many of the conferences in this current field. So, with this introduction, I welcome you again, sir. Sir, your audio is not there.
Yeah. Now I think it is
Yeah,
there, right?
fine, fine, sir.
Actually, this Webex is actually relatively I'm less familiar. We are more using either the Google Meet or the Zoom. So
Yes,
yeah. Yeah. I think now my screen is shared. Is it
uh,
okay?
yes, sir, it is shared. Yes, sir. Yes, perfectly fine, sir. It is
Oh,
perfectly visible and transition. Can you, sir, move to another slide? I want to just check the transition.
is
Yes,
it
yeah, yeah, it is
is it
there.
there?
Yeah,
Is
completely.
it there? Okay.
Okay. Over to you, sir.
Okay, thank you so much. And I have around 1 hour. So, I just want to understand whether the participants can unmute themselves and can ask the question, or
So they
it's a
can,
one-way.
yeah, they can write their question in chat box, sir. Hello. Hello. Sir, you are not audible to me.
Is it okay now?
Yes, sir. Now it is. I'm getting it.
Okay, I connected my with my iPhone, so now audio will be from the iPhone, right? Okay,
Okay.
let me check if it is okay. Is it okay?
Yes, sir. This is fine.
Okay, so video is from the system and audio from the phone. Okay. Mm, okay. If there is any question in the chat box or any query, you tell me, because I'll not be able to see any query when I'm making it full screen, right?
Okay, sir. I will read from the chat box and along with
Right.
you one by one.
Right. Thank you so much.
Okay, sir.
Um, First of all, good evening, everybody, and thank you so much, Dr. Nanda, Dr. Hila. Thank you so much for this opportunity. I'm really very happy that consecutively, I think this is the third year that I'm delivering my lecture in this EICT Academy workshop. It's actually a great initiative and a wonderful platform for learning optimization from the good speakers, good number of speakers, variety of topics have been covered. Good initiative. Thank you so much. I'm going to speak on the artificial bee colony algorithm. Before I start, I just want to explain that what you are going to learn and what you are not going to learn, not to learn. Uh, in this 1 hour, I just want to make you promise that I'll be able to remove the inertia of understanding the introduction of artificial bee colony algorithm. I will explain how this algorithm works, why this algorithm is required, for what kind of problems this algorithm is being applied, what is the major inspiration, and how actually you can code this algorithm. I will take a numerical example so that you will be able to understand that how to code this algorithm. uh, uh, you can expect the basic introduction of this artificial V colony algorithm, but cannot expect the expertise in this algorithm, because in this 1 hour I will able to explain the algorithm, but will not be able to explain the pros and cons of this algorithm. Will not be able to explain you the research perspectives of this algorithm, right? So I'll let me just start artificial bee colony algorithm. First of all, uh, artificial bee colony algorithm is inspired by the honeybees foraging behavior. It is a swarm intelligence based algorithm. It is for the optimization problems. First of all, I want to tell you that this algorithm is for the optimization problems. Optimization, whether it is discrete optimization, continuous optimization, binary optimization, you have an optimization problem, this algorithm can be applied. But there is a warning: when you apply this algorithm to any optimization problem, if you have an optimization problem which can be solved using traditional mathematical methods, then my recommendation, not to apply this algorithm. If you are not able to handle your optimization problem using traditional optimization problem due to various reasons, for example, your algorithm, your problem is not continuous, not convex, not differentiable, or you are not aware that whether your problem is a single unimodal or multimodal, means you have, you cannot determine that this particular traditional mathematical method can be applied to this optimization problem. If you cannot do, only then this algorithm is recommended. Why only then? Because this is a probabilistic algorithm. Probabilistic algorithm means where you are making the decisions based on some probability, based on some probability distribution. And when you are making decisions in solving a problem using some probability distribution, then definitely your answer is also probabilistic. Means there is a probability associated with the correctness of the answer. Your obtained solution, the optimal solution obtained using ABC, artificial bee colony algorithm, of an optimization problem is not guaranteed to be correct. It may be incorrect also. It may be near optimal. So whenever we solve any problem using this algorithm, we always say that the obtained solution is a near optimal solution. It is not a true optimal solution. If you solve an optimization problem, suppose LPP, using simplex method, you will always say that it's a true optimal solution. But we will not be able to say for this algorithm that you are dealing with a true optimal solution. We always say it is a near optimal solution. Therefore, I always recommend, whenever you have an option to get the true solution, why to manage with the near optimal solution? When you can get the exact solution, why the approximate solution you will go with? And therefore, if you can apply the mathematical methods to solve your optimization problem, don't go with this. But in case of real world situation, there are many problems which otherwise cannot be solved using traditional methods, and therefore artificial bee colony algorithm, kind of swarm intelligence algorithms, are very very useful, because these are only the life savior at that time, are only the savior at that time, because all the mathematical algorithms fails. Artificial bee colony algorithm is one of the leading algorithm in the field of swarm intelligence based algorithm. It is inspired by the foraging behavior of honeybees. Honeybees are, there are three types of honeybees actually. I wrote it two types here. I'll tell you that what is the third type. There are three main components in the forage selection or foraging behavior of honeybees. One is the food source, and food source in case of the honeybees are the flowers. There are the honeybees which rest on the uh, flower, which are extracting the nectar from the flower. This bee, they are called the employed bee. And the bees which are actually not extracting the nectar, but they are on the hive, they are actually called the onlooker bees. They are just resting and looking for the information. That's why this is called onlooker bees. They are looking for the information. There is another kind of bee in under the category of unemployed bee, that is called the scout bee. Scout bees actually, what happens, the bees are extracting the nectar from the flower, and her stomach is not full. What they do, they extract the nectar from the flower and then they return to the hive to unload the nectar. But before her stomach is full, the nectar in the flower is exhausted. In that case, what they do, they leave that flower and go to some other another flower. So during this time, when she has left the flower and in search of another flower. During this time, this bee is called the scout bee. Scout bee. So actually, there are three types of bees: employed bees who are extracting the nectar, onlooker bees who are resting on the hive for the waiting for the information from the employed bee, and the third is the scout bee who are searching the new flowers. Three types of bees. Based on these three type of bees, artificial bee colony algorithm, in artificial bee colony algorithm, I said algorithm, this is a real situation. In the algorithm, we have defined three phases. The algorithm works in three phases based on the three B's: employed B phase, onlooker B phase, and the scout B phase. So once we understand these three phases, the algorithm is done. Okay. And yeah, food sources. The another one is the food sources. I already told that food sources are the flowers, and in our algorithm, the flowers are nothing but the potential solutions. The swarm size, number of flowers equal to the swarm size, and this number of flowers is also equal to the number of employed bees, because we, in the nature, it may not be there. Number of flowers may be less, number of employed bee may be more, or number of flowers may be more, number of employed bee may be less. But in our simulation, in our algorithm, all these algorithms are the nature inspired algorithm. They are not the simulation of the nature, and therefore, we take the flexibility to for algorithm kind purpose, as compared to the natural phenomena. So we consider that the number of employed bees and the number of flowers are same, and that is the swarm size. That is the swarm size here. Okay. Foraging. Foraging. How they do the foraging? Let me just explain you. There is a bee on the hive. It starts in search of. It starts flying in search of the food, in search of the flower where she can extract the nectar. She found some flower, start extracting the nectar. Once her stomach is full, she will return to the hive. But if her stomach is not full, she will search some another flower. During this period, she will be called scout bee. As soon as her stomach is full with the nectar, she will return to the hive. After returning to the hive, she will unload the nectar to one of the comb of the hive, and one after unloading, she will put some substance to avoid the fermentation. And after doing all this job, now the job of this honeybee who is returning from the flower, to this, to inform whatever the information she has to other bees on the hive, which are onlooker bees. So she will inform to the other bees and give the information that from where I am coming, in which direction this flower is, what kind of flower it is, how much nectar it has, whether other bees are there or not, how far it is. All this information will be shared with the other bees, that is the onlooker bees. And this information sharing is done by the different kind of dances. They do the different kind of dances. Actually, they do three kind of dances based on the position of the flower from the hive. And all this information is to be shared. Let me tell you these three dances. They perform three dances. First is the round dance. If the distance of the source to the hive is less than 100 meters, what I said, that suppose this is your hive and this is the position of the flower. Here so many flowers are there, and this is the hive hive where the bees are resting. Now if this distance is less than 100 meter, if this distance is less than 100 meters, then they do the round dance. Actually, if less than 100 meters means the flower is quite close to the hive, and therefore there is no need to give the information of the direction, only the distance is given. So if the bee is doing the round dance, it means the flower is close to the hive, and the onlooker bee for which she's dancing, she has to search the direction, right? Only the distance information is to be given in this case. But if the distance is greater than 100 meter, if the distance is greater than 100 meter, then this we do the waggle dance. And let me tell you, we consider that always this bee is given is doing the waggle dance. We are in the algorithm, we are not considering this third dance, tremble dance and round dance. We are considering only the waggle dance. I told you that it is a nature inspired algorithm, so we take this liberty to take few concepts and not to take other concepts, because you understand that the nature is the god's phenomena, and we can't simulate in a computer program the nature. It's a complete god cannot be simulated. So waggle dance, we are simulating few aspects of the natural phenomena. So waggle dance. If it is greater than 100 meter, then they do the waggle dance. Actually, in the waggle dance, they give the information of the sun, of the direction also, and this direction information is taken from the sun as a reference point. When this bee is do is when this bee is extracting the nectar at this flower, the sun was at this position. So when the bee is doing dance here, she will always do the dance like this. She will always do the dance like this. Please see my cursor movement. This is important. She will do the dance like this. So you see, she will make this same angle where it was this. So now other bees understand that in which direction this flower is. So they will also make the same direction with the flower, and taking sun as a reference point, it will give the information uh, of the direction of the flower. Tremble dance is, I'll show you in my next slide. There is a video where there, where there is a real video of the honeybee doing the waggle dance. So in that video I will explain more on the waggle dance. Before that, the tremble dance. When the foraging bee perceives a long delay in unloading its nectar, so tremble, then they do the tremble dance. Tremble dance means if the information is delayed. If she has performed dance here, now she is performing the dance at this area of the search of the hive, or she has taken a lot of time in giving this information. If the information is delayed, then she do the tremble dance. She did do the tremble dance just to inform other bees that this information is a late information. If you want to go there, you may go, but since this is a late information, so the situation may have changed. Other bees may have extracted the nectar from that flower, so whatever the information I am giving you may not be the correct information. And therefore, this is the reason why this tremble dance is not implemented to the algorithm, because there is no such kind of delay in the algorithm. Because in the algorithm, as soon as the solution is updated, it can be shared with other members, right? So there is no such kind of delay in algorithm, and therefore there is no need to do the tremble dance. Okay, this is the one video that I was talking about. You please see carefully. Please see the documentary also, the sound also. So I hope you will be able to hear the sound. If not, just let me know.
This honeybee is collecting nectar from a purple Kuthia flower. If the food source is farther away, the scout or foraging bee performs a so-called waggle dance. The bee follows a figure eight and waggles on the middle line of the figure eight. The waggle dance tells the other bees in which direction to look for the flowers. If the bee waggles straight up towards the sun, the other bees will find the flowers by flying straight towards the sun. If the bee waggles to the left of the direction of the sun, the flowers can be found by following that direction. The speed of the waggle dance gives information on the distance of the flowers.
I hope you can understand that this speed of the speed of the dance can give you the distance, that if the speed is fast, speed is slow, and it is according to the distance of
From the hive. If the food source is close, the bee waggles faster. The foraging or scout bees also bring.
So speed of the waggle dance is actually inversely proportional to the distance between the hive and the flower.
Back the special scent of the flowers, which gives additional information of the food source to the other bees.
Okay. So now we are coming to the artificial bee colony algorithm. Foraging part is done. So how this concept is converted to an algorithm. So there are three types of B. I already told you: employed B, onlooker B, and scout B. Based on these three types of Bs, there are three type of phases. The algorithm is implemented in three phases. One is the employed B phase, another is the onlooker B phase, and the scout B phase. I already told you what are the employed Bs. They are extracting the nectar. Onlooker bees, they are waiting for the information at the hive. Scout bee are responsible to search for the new solutions because their stomach is still not full and the solution is exhausted or the flower is exhausted. Okay. In our simulation, as such in the nature, the number of employed bee and number of uh, onlooker bees may be different, but we will consider that the onlooker bees and the employed bees are equal, right? So that the employed bees are equal to number of flowers. So look carefully: onlooker bees, employed bees, and the number of flowers all are same, equal. Number of flowers equal to number of employed bee equal to number of onlookers, so that we can assign each employed bee to each flower. Means we can consider that this is our potential solution, and when this employed bee returns to the hive, she can be replaced by one onlooker bee, right? So it is actually convenient to, in terms of the algorithm. Therefore we are taking number of onlooker bees equal to number of employed bee equal to number of flowers, right? But in nature they may be different. Okay. Okay, I'll explain you the algorithm, working of the algorithm using this pseudocode. Once we understand this pseudocode, algorithm is done. First of all, like any other swarm intelligence based algorithm, we will initialize the population, evaluate the population, we will calculate the objective function value. Initialize the population means you will generate the solutions randomly. They will represent the flower positions. Evaluate the population means you calculate the objective function value. Then iteration starts. All these algorithms are actually iterative algorithms. You must have studied by now, you must have studied one or other swarm intelligence or evolutionary algorithm. Madam Professor Deep, who is my teacher, must have explained you just now the genetic algorithm. As I understand, she was delivering lecture on genetic algorithms. So like genetic algorithm sees the this algorithm is also the iterative algorithm, then repeat, and then produce new solutions. New solutions are produced using this formula, the one most important formula. If I'll be able to explain you in next 5 minutes this formula, the philosophy of ABC will be clear. Let me tell you how. You know, the new solution, uh, let me not call it new solution V, which is updated position, updated solution, equal to the old position plus one coefficient, this phi, which is a random number in the range -1 to 1, multiplied by 1 x, this current position, minus randomly selected solution of the population. This is the equation which is actually the basic equation of ABC, and this is the one which will be applied to the onlooker B phase also. And the logic is very simple. Let me tell you how it is, how it works. Suppose this is the current solution or current B, and it is taking inspiration from this B. Right now this B is selected. This is your XR position, actually XR. So this is your XR and this is your X. If I write X minus XR, then this is a vector, this vector, then this is this vector. And if I take this minus XR, then this is this vector. I hope you understand that X minus XR. So it will be XR minus X. I hope it is okay. It will be this vector and minus XR. Let me write like XR minus X, right? So it is this vector. XR minus X means XR, sorry, let me make it XR, right? Sorry, plus XR. So XR minus X will be this vector and XR minus X will be this vector. So if this phi is negative, if phi is negative, then direction will be this. If this phi is positive, then the direction is this. What I want to tell you, since this solution is randomly selected, this is not the best solution, and therefore I'm not sure whether going towards this solution, is a good idea, or going away from this solution is a good idea. And therefore the coefficient is negative and positive both, and this x will move towards this solution. This, let me write it here again, x will move towards xr, and it will move, and suppose it came here based on the phi, it will be based on the phi and this difference and this difference. So it is here, and now it became this is your v. If it the direction is this, then this is your v, this is your v. This is how the solutions are updated. I hope you are getting my point, that in all the optimization algorithm, whether it is deterministic or probabilistic, the new solutions, this is the fundamental rule for all the optimization. New solution equal to old solution plus lambda, and let me call it h, lambda h. Lambda is the direction and h is the step size, lambda h. So here this phi is the direction and this is your step size. This x minus xr is the step size. So this is how we decided h here, and this is how we decided lambda here, the direction. And once we get this solution, now this solution may be worse than the previous solution and may be better than the previous solution. So we do not know, because it is inspired by the randomly selected solution. If this would have been the best solution, then definitely the updated solution will be better than the previous solution. But since it is inspired by the randomly selected solution, we have to apply the greedy selection. Next step, we will calculate the function value at the updated solution and will compare with the function value at x. Whichever is better, we will select that solution. Greedy selection means if v solution is better, we'll keep the v. If x is better, we will keep x. Okay. This is the employed B phase. This is done. We are done with the first phase. There are three phases: employed B phase, onlooker B phase, scout B phase. In employed B phase, what we are going to do, we are going to update all the solutions using this formula. All the solutions will be updated using this formula. Now, the onlooker B phase comes. In the onlooker B phase, what happens? Only the B's which are giving good information, which are giving the information about good solutions, only those B's will be followed, and the bad flowers will not be updated, will not be followed. If somebody is saying that I'm coming from a flower who is exhausted, then other bees, the onlooker bee, will not go to that flower. So the good solutions will be given in the onlooker bee phase. The good solutions will be given another chance to get it updated. And how it is calculated? Using this formula based on the fitness. Means if xi is a one solution and its fitness is suppose fi, then xi will be updated in the onlooker B phase or not. It is proportional to this fitness. The probability of getting updated xi is proportional to this fitness, and therefore the probability of xi for updation, let me write like this: probability of xi, means probability that xi will be updated, is proportional to the fitness. And since probability is to be between 0 and 1, so of course scale it and for scaling you just divide it by the sum of the fitnesses. You have calculated this probability. Now this formula is just to calculate the fitness in terms of the uh, from the objective function to the fitness. It is calculated just to make sure that it is always maximized. If your problem is minimization, then objective function sometime minimum is better. If the problem is maximization, then maximum is better. But if you convert it into fitness, then it is always to maximize. Higher is a better. Okay. Now let's start the onlooker B phase. Now in onlooker B phase, what we do, we update the new solutions. We update the solutions using this probability, and you get the VI using the same equation. Equation will remain same. How it works? Actually, suppose X1 is a solution, right? X1 is the solution, and its probability is P1 using the formula in the last slide. So now what we will do, we will generate a random number between 0 and 1, and if it is less than P1, we will apply this equation, V equal to X plus phi X minus XR. This formula will be applied. This formula will be applied to X1 if the random number between 0 and 1 is less than P1. If not, then this solution will not be updated. Now you just imagine, if this P is large, P is large means the fitness is good. It means there is a high chance that it is get updated. It is getting. So the good solutions, the role of onlooker B phase is that good solutions are updated many times. Onlooker B phase is making sure that the good solutions get updated many times, and the bad solutions should be eradicated from the population, from the swarm. Using the same technique, we will again apply the greedy selection approach for the between the onlooker bees and xi and vi, and we will do it equal to the number of flowers, equal to the number of onlooker bees, equal to the number of employed bees. Same. Okay, here I just want to mention that in some books you may find the formula x as x minus xr or xr minus x. It is same because the coefficient is negative and positive both. So there is no problem if you write x minus xr or xr minus x. Okay. Now here is the scout. Oh, sorry. Onlooker B phase done. Now we will start with the scout B phase, the third phase. Actually, what happens in the nature? If the flower does not have no more active, no more nectar in the flower, then the bee will leave this flower and will search another flower for extraction. Now this concept is simulated in the algorithm by considering that whether the given solution is abundant or not. Abundant solution means if the solution is not updated, if the solution you are updating the solution and it is not updated up to a certain number of iterations. If continuously solution is not updated, we will declare that this solution is abundant solution, and we need to kill this solution, and we will generate a new solution, and the new solution will be generated using simply the random generation formula. So randomly the new solution will be generated in the range of min to max, in the range of this. So scout B phase is actually not implemented or is not executed every time. It is executed, it becomes active only if there is a solution which is not updated up to a certain number of iterations. And this certain number of iterations up to when the solution is not updated is called the parameter limit. We call it limit. There is a parameter, and usually in ABC this parameter is set to 100. Limit is set to be 100, right? Memorize the best food source position, increase the cycle, and stop the algorithm until the maximum cycle attained. So this is the complete pseudocode of the algorithm. Let me just quickly summarize. Artificial bee colony algorithm works in three phases. One is the uh, employed B phase, onlooker B phase, scout B phase. In the employed B phase, we update all the solutions. In the onlooker B phase, we update only those solutions, or we update the solutions based on the fitness. If higher the fitness, higher the chances. And in the scout B phase, only those solutions are randomly generated which has not been updated up to a certain number of iterations, that is the limit, and which is set to be 100 in our case of artificial bee colony algorithm. So this is the basic idea behind artificial bee colony algorithm. Let me take one numerical example to better explain this, so that you can code also. You can make a code after learning this numerical example. You will be able to make the code of ABC very easily. Okay, let me explain. You have this two variable problem, minimization problem. This is the range in which you have to find the optimal. Of course, you already know that the optimal solution is 0 0 and the optimal value is 0. Colony size is this 6, but this 6 means 6 means uh, um, 6 means including the employed bee and the onlooker bees. So your actually the swarm size is 3. The number of flowers, 3 is the number of flowers, number of onlooker bees, number of employed bees. And yeah, limit. Currently I'm taking, just for handout example, I'm taking it 6, but usually it is set to 100. Dimension is 2 because there are two variables. Okay. First step is the random initialization. You generate 3 solutions randomly. This is your first solution, second solution, third solution, randomly in the range -5 to 5. Calculate. Next step, you remember the next step was evaluate. Calculate the objective function value. Just put this to x1 square plus x2 square. This was your objective function. Put to this, you will get this value, right? So calculate the objective function values. Calculate the fitness using fitness formula. This is initial fitness vector. You can see that this is the highest fitness. It means your third solution is the best solution. Third solution is the best solution at this moment. Okay. This is the quality of the food source or the best solution. Okay. Let's start the employed bee phase. First phase is the employed bee phase, then onlooker bee phase, then the scout bee phase. And in the employed bee phase, we will update all the solutions, and all the solutions are updated using this formula. And this formula is applied to one of the it's a two dimension solution, two variable solution. In the artificial bee colony algorithm, we will update only one dimension at a time, and this one dimension is at a time selected randomly. So for first solution k is randomly selected index, so k equal to 1. Actually this index is started from 0 1, so it is actually a second variable. K equal to 1 means second variable, and j equal to 0, so j is a random selected index, so j equal to 0 means first variable. Okay, so k equal to 1 means your second, this randomly selected solution is the second solution, and j equal to 0 means the first variable will be updated, and phi randomly generated in the range -1 to 1, you will get this. And when you will put in this formula, means you have, let me just quickly uh, erase this, clear this, just to better explain further. Okay, what I want to tell you, that you want to update this solution. In this solution, the j equal to 0 is selected randomly, so it means you are going to update this solution. So the 1.4112 plus whatever is the phi value, I think it was 0.58 something, multiplied by 1.4112 minus, and k was equal to 1. K equal to 1 means this part, k equal to 1 means this, so I will write here 0.4756, and after solving this, this will be equal to whatever he obtained here. We obtained this, whatever we obtained this, and the second variable will remain same. You can see here the second variable remains same, no change, it remains same. So this is the first employed bee has been updated. But I told you that after this we have to apply the greedy selection, and for greedy selection you have to calculate the objective function value at this point. So this is the objective function value, and this is the fitness. Previous fitness was this, and this is the current fitness. So your solution is not actually updated, is not become better, it become worse. And since it becomes worse, so we will carry the previous solution as it is, right? Solution remains same also, so solution 0 could not be improved. But what we will do, since this solution is not updated, so we will start one counter, that is called the limit counter. So the trial counter will be increased by 1. So initially, suppose my trial counter is denoted by T. So T was initially 0 for this first solution. For the first solution, it was 0, but now it became 1 because it is not updated one time. Similarly, we will update the second employed B. Uh, we will update the second employed B using the same formula. This time you can see that k equal to 2 means for second employed B, the third solution is selected randomly and the second dimension is to be updated, and this is your phi. If you will apply the same formula, you will get this here. I hope I'm so you can see it that this solution is updated, and this time it will be updated and it will remain same. 0.4756 will remain as it is. Okay, so this will remain as it is and it is updated. Now fv1 and the fitness of v1, you will calculate the fitness value, calculate the objective function value at this point, and you get this objective function value, and you can see that this is the fitness value. And this time this fitness value is again not updated. It is still worse. Again, even for the second time, the solution is not updated. It is worse than the previous solution, and therefore for the second solution also t2 also become 1. Means for the second solution also the trial counter become 1, right? Now we will apply the same procedure for the third employed B. Again we will apply the same formula, same formula, and this time k equal to 0 means for the third employed B, for this sorry, let me just erase this. For the third for this third employed B, you are selecting this first as the random solution, and j equal to 0 means first dimension will be updated. First dimension means this will be updated and it will remain same. It will be updated with the help of this. Okay, let's do. Okay, and this is your phi. You can see here that this time it is negative also. So if it remains, it is updated. I think sorry, first solution is updated and second is same. Calculate the objective function value, calculate the fitness. The new fitness is this, and you can see that this was your previous fitness and this is your new fitness. This time it is updated. The solution 2 is updated. This last solution was updated, and therefore we will consider in our population the updated solution. This solution will be considered and previous two solution will remain same, and its trial counter will be 0. Means t3 will be 0 because solution is updated. No problem. Okay, now in order to apply this employed B phase is done, all three are updated. Now in order to apply the onlooker B phase, you will calculate the probability. This is your probability vector. You will put all the fitnesses in this formula and you will calculate this. You can see that the third solution is best solution, so its probability is also very high. Means the third solution, since it is better solution than others, and therefore the probability of its updation in the onlooker B phase is higher than others, right? Okay, let's update. For first onlooker B, first of all, for first onlooker B will go to which flower? It is the same like first onlooker B will go to which flower? So it is obvious that the probability is higher that it will go to third flower, right? So what we will do for first onlooker B will generate random number between 0 and 1. And if this random number between 0 and now, first of all, we will actually create the cumulative probability. So what is that? 5 4. Let me just two decimal place, and this will become 9 and 9, right? Actually it will become 1. Actually when I will add full, it will become. So if you will generate a random number between 0 and 1, and if it is less than 0.11, then the first it will go to first flower. If it is between these two, then it will go to second flower. If it is between this, then it will go to third flower. So obviously this difference is higher, this difference is very large, this range is very large, and this range is small, and this range is further small. In other words, it is called actually the roulette wheel selection. So it is like this. This is for first B, this is for the uh, just a second. This is for the second B. So you can see this is for the first B, second B, and this is for the third B. Third B area is largest. So there are very high chance that in the roulette wheel selection, the ping pong ball will come to this area. Similarly, it happened that the first onlooker B is going to the third flower, and we apply the same formula, calculate the objective function value, calculate the fitness, compare, apply the greedy selection, and it is not updated. First onlooker B again is not updated, and its trial counter will be increased. Okay. Now, the second onlooker B. Now, second onlooker B, again we will generate a random number between 0 and 1, and if it is less than 0.11, then it will go to the first onlooker B. If it is less, if it is between 0.11 and 0.45, then it will go to second. So actually what happened here, the random number this time between 0.11 and 0.45, and therefore it is going to the second employed B or second flower. Again apply the same formula. This is updated solution. Calculate objective function value, calculate fitness, apply the greedy selection, and the solution is updated. Solution become better, and therefore the trial counter will be 0. Means now T2 will be 0. Earlier it was 1. Okay. The third onlooker B. You see here, for the third onlooker B is also I equal to 2. It means what happened for the first, and this is for the second. You see here, 2 B's are there and 1 B is here and no B is here. It is the case. Means good flowers has 2 B's, bad flowers has no B, and mediocre flower has only 1 B. Again it is updated. Objective function value, fitness, apply the greedy selection, again updated. It is again updated, and in this case again the trial counter will become 0. Now you see here, this is the best solution. Again the third solution is the best solution, and the trial counter for the first solution is still 1, and the second and third it is 0. For one cycle is done, one iteration is done of the artificial bee colony algorithm, but scout bee phase is not activated at this moment because my limit is 6. I set the limit 6, and since the trial counter has not reached to 6, it's still 1. Means if the solution is not updated in one iteration, we will not regenerate it. If it is not updated even up to 5 iterations, we will not regenerate. But if it is not updated up to 6 iterations, we will regenerate it randomly, right? Since at this moment it is 1, we will not activate the scout b phase. But just imagine it would have been 600. In that case, this first solution will be regenerated in the range -5 to 5. Will generate randomly in any solution for this first solution, because we will consider that since up to this number of iterations solution has not been updated, and therefore this solution has no more uh, energy to get updated, and therefore we will stop here. uh, Scout B phase is done. We will continue this process. This is an iterative algorithm, and therefore we will continue. If you are happy with the best solution, this solution, you stop here. Otherwise, again, update, again apply the employed B phase, onlooker B phase, Scout B phase. Keep on continue until you are satisfied with the solution. I tell you that usually the artificial bee colony algorithm is very, very good for continuous optimization problem as such. It has been applied to the discrete optimization problems also, but for the discrete optimization problems, ant colony optimization algorithm is a better choice as compared to the uh, artificial bee colony algorithm. So, for discrete optimization, ant colony optimization better choice. This is not that good algorithm. For continuous optimization algorithm, this is a wonderful algorithm. Very simple, very easy to code, and very fast as compared to the particle swarm optimization. If you have studied PSO, particle swarm optimization, you can observe an inbuilt difference between the PSO and ABC, that this algorithm has inbuilt mechanism of stagnation. in PSO, if the solution is not updated, there is no mechanism whether it can help the swarm. But here, if the solution is not updated, it is regenerated in that particular phase, and therefore this algorithm gives you better accuracy. If the problem has many local optima, then this algorithm can work better, because even if the solution is stuck to the local optima, this algorithm has an inbuilt mechanism to get out of that. PSO doesn't have. PSO doesn't have. It, differential evolution also doesn't have, but this algorithm has, right, inbuilt mechanism of coming out of the local optima, and therefore this algorithm is now very famous for continuous optimization problem, very easy. And of course many uh, many uh, update in this algorithm has been done. You can of course you can study some recent research papers which are worked on this, which have proposed the update in the ABC algorithm, which has the update in the ABC algorithm, and you can understand that what kind of update or what kind of research is being done in the artificial bee colony algorithm. Just for your information, one, I tell you that you have this formula, you have this update formula. Just for time being quick, I tell you research idea. As such, this 1 hour lecture is not related to the research idea, but it is randomly selected. This solution is randomly selected. You can think of another term phi, where it is inspired by the best solution also. Sorry, best will be written here, right? Xg minus x, you can write like this. This concept is inspired by the PSO. In the PSO, best solution is there, so you can select the random also and can the best also. Of course, do not remove this term, because this is the USP of this algorithm, that it is always exploring the nearby areas. Okay, so that's all from my side. Thank you so much, and I'm okay to take few questions if you have. Thank you so much. Professor Ela, somebody said that I'm not audible. Am I not audible?
Sir, you are perfectly audible. This side,
No.
Dr. Nanda and Dr. Ila is
Okay.
also here.
Yeah. Yeah, Professor Nanda. Good to see you.
Sir, I sorry at that time I was waiting for
I understand. No
exam
problem. No
duty.
problem.
So
Okay. So I can
one
see one question, Sakshi Rajput.
yes,
How
sir.
can we make the results of GA or BCO? BCO.
B colony optimization.
I think he's.
B colony optimization.
Oh, it is called ABC, not BCO.
Uh,
ABC. How do we always get the same output for an input? No. Same output, if you want to get, then for the random numbers generation, you need to keep the seed same. Computer generated random numbers are actually the pseudo random numbers, and they are generated using uh, a congruence based equation. And for the congruence, that congruence equation has a seed always. And default rand command in the code, the default rand command takes the system time as the seed. If you keep that fixed, you will get always the same output, right? But it is not recommended. It is not recommended that you keep it fixed, otherwise your algorithm will lose the diversity. Yeah. Yes, Jayashree, to optimize multiple parameters such as gain, shift, coefficients of a filter. Yes, for these kind of problems, the ABC and ant colony automation are there. But I don't know. You say that ABC and ant colony. So if your problem is discrete, go with the ABC, go with the ACO. If your problem is continuous, go with the ABC. This is very controversial question. Jayant Mani Tripathi, which is better algorithm, hybrid GA, NLP or ABC? First of all, we can never.
Sir, your video is. Can you make
No,
the video?
my video is on.
Uh,
I have not switched off my video. I don't know why it is not coming.
no, no. Now it is available, sir. Sir.
Okay, okay. So, uh, mm, GA, NLP, or ABC, actually, in these for these kind of algorithms, we cannot compare the two algorithms. It all depends upon the problem under consideration, that for what kind of problem you are solving, and therefore, you cannot say that this algorithm is better, that algorithm is better. It is always based on the experiments. You solve a problem, if you find better results, you can declare that okay, this algorithm is better than the other. I don't know. This ABC is best suited for a time series, for example, rainfall. I don't know this time series analysis you are doing as an optimization problem or not. If you are modeling the time series analysis for rainfall as an optimization problem, then definitely ABC is better, right? So ABC is good for optimization problems, right? Remember, it is not good for the prediction purpose. Of course, even if the prediction problem can be modeled as an optimization problem, then you can apply the ABC algorithm. Okay, I think I have answered all the questions.
Sir, just 1 minute.
Yeah.
People are still posing some question. They are posting it.
Why optimize something in according B? Is there a way to stabilize or fix root of B's? I could not understand what to. Why optimizing something in according B colon dimension? Is there a way to stabilize or fix root of B's? I don't know why this question is. There is no meaning of this question actually.
Hmm.
Means
Any other questions from participants?
yeah.
Hmm.
Okay.
Yes, sir.
Any
Sir, actually, these all optimization algorithms and the neural networks, all these are related to the fundamentals of the soft computing techniques. And you are also the general chair of the Soft Computing Research Society. So there are large number of participants. If you can able to say a few words about the society and how the participants will get
okay.
benefit,
Okay. I
then it
just
would be
forgot. I was just forgot. Can you see my slides?
yes.
So this is Soft Computing Research Society, and I formally welcome you to join the society as a member. Uh, the Soft Computing Research Society website, you can just Google about this, and you will you will find all the details. Uh, this is established in the year 2013, and under the society, we are training the undergraduate students also. We have very recently started one technical magazine also, SCRS Insights, and we are of course technically sponsoring many conferences, including Professor Nandaj at MNIT Jaipur. Professor Nanda is the general chair of one of the most successful conference at MNIT Jaipur, and we are sponsoring that conference as well. So please visit scrs.in, and if you are into the research, publications, development, if you are a student, you are a faculty related to computer science, related to soft computing, artificial intelligence, uh, definitely you are recommended to join the SCRS in one or other ways. uh, all the all the activities of the Soft Computing Research Society are available on the website. You can join the society as a member. You can join the society as a conference organizer, or of course you are always welcome as a reviewer also for various conferences. Yeah,
Thank
Professor.
you. Thank you, Jagdish sir, for enlightening the participants about the uh,
And Professor Nanda is one of the significant player in the Soft Computing Research Society. Let me tell you, he is a member of the core committee and advisory board also.
Thank you, sir. Sir, tomorrow also your session is there for on drone swarm
Yes.
concept. So that will be also a very interesting one for all participants to
Yeah.
listen to.
Yeah, my pleasure. And actually, it is really my pleasure to interact with the faculty members throughout the India. It's really a very successful program, Professor Nanda. Thank you so much.
Thank you, sir. Thank you. Good night, sir.
Good night. Good night. Good night. Good night.